Hi again, this is problem number 54, or very close to it, from section 6.3. And this one actually, you have to graph it using transformations as well. So you have to graph the function -2 times e to the negative x plus 3. So I first graph what I'd call the parent function, e to the x. Now e to the x, remember e is Euler's function, which is approximately 2.718, and it can be found on the calculator. But if you take that 2.718 and you raise it to the 0 power, you get 1. 2.718, or e to the first is 2.718, and then the next one will be like 7 point something or another. Okay, but at the end of the day, e to the x will look very close to like 3 to the x. Maybe not quite as steep, but it's steeper than 2 to the x is. So it looks like the 2 to the x and 3 to the x graph. So then you take that graph and you apply the transformations that they're being asked you to do here. Well, e to the negative x is a horizontal reflection. So you take this graph and you flip it across the y-axis. So just the negative x there will take this graph and bring it to the other side. So it looks like this. Now that is just e to the negative x. So let's make that dash because that's not my final answer. So that's e to the negative x. Okay. Now the 2 will stretch it. So it'll stretch it from the x-axis on this one because it's 2 times the function. So you take this 2, that's at 2.718, double it, and that'd be about 5.4. 1, 2, 3, 4, 5.4 is about right there. But that's just when it's being multiplied by 2. If it's being multiplied by a -2, it's going to be at -5.4. So it's down here. So -1, 2, 3, 4, 5. So -5.4 is about right there. And this one right here, that's at 0, 1, double it makes it at 2, but it's a -2, so it flips it over. So it's at -2. So the graph is just a lot steeper. Okay, so it's the negative will flip it upside down, and then the 2 will stretch it. So if you look at this one, it looks a little bit skinnier than what I had before. And then finally, the +3 just takes this dashed graph down here and then just plops up 3 points higher than what it already is. So finally then, if you want to put it on a different graph, that might be better on this one. So you take this point right here and just move it up 3 units. 1, 2, 3. So that goes back to 1. And this one at -5.4 will now be at -2.4 because you moved it up 3 units. Now, you would think it would look like this, something like that. And you'd be right, except the problem is there is a horizontal asymptote, and that's at 3. So if you just leave it like that, which is what a lot of people will forget to do, that horizontal asymptote, and this is what they will give me. And the problem with that, you're going to lose some points for that. Because to me, when I look at this, if I have no clue what the graph is supposed to look like, and I look at this answer, and I don't know what's going on here with this +3, I'm going to assume this graph continues up. So what you have to do is go up to 3 and make it a dashed line to let the person who looks at your graph know that this graph levels off at 3. So indeed, there is a horizontal asymptote. So in these exponential functions, you got to remember this number that's out here alone by itself represents the horizontal asymptote. That, no matter what problem it is, that's what that number is. And if it is 1, 2, 3. So very close to number 54, slight variation, but it's on the same level. So, and that's it.